Okay, Passerians, welcome as we do some linear and angular speed problems here for pre-calculus honors, okay? You're in this class because you are an honorable person. So we are going to try to find the angular speed of the blade, not the blade, the blade. I said blade, in radians per second. So I like to put that as my goal down in the bottom. And I've got a circular saw blade with a 9-inch blade. I'm just thinking of like a circular saw. Those are very dangerous. So please, if you are using a circular saw, use precautions. Use the push stick. Don't try to like put your fingers right through that blade. Okay. So we got a circular saw blade of 9 inches diameter. But diameter is not really our thing. We're more into the radius, so that's 4.5 if you want that. And it does go at 2,800 revolutions per minute. Okay. Now, we have been talking a little bit about how science teachers or science students might go at this versus how math students or math teachers would attack it. So let's talk a little bit about how science does this. What they do is they make what they call a train track. And they try to get rid of minutes by putting 60 minutes, which is in fact, oops, sorry, I already messed it up. We want to go to seconds, right? So we put 1 minute, which is 60 seconds. And that will get us the seconds we're looking for. So if we just cancel these out, we're there. Okay, now just because I have space underneath it, I just want to show kind of like the mathematical idea of this. We're taking 2,800 rev. You don't have to write this part if you don't want. And we're multiplying it by 1, which is 1 minute per 60 seconds. The minutes will cancel. And then we'd multiply again. So what they're going to do to keep you organized is they're just going to add what they call a train track here. And they're saying, okay, well, the seconds are already good to go. Now I need to get the revolutions out of there. And instead of the revolution, so I want to get one revolution gone. I want one revolution gone. What could I find that is a revolution? This is the most important and most difficult part of the problem. It's to understand how do I get a revolution to a radian, or a revolution to inches, or a revolution to feet. And so we're going to put on the side here, in the left side, we're going to say what one revolution equals. One rev must equal how many radians? So one rotation is 2 pi radians, 2 pi rad. So it's very confusing because it could have been 2 pi r, but it's actually 2 pi rad because 2 pi r follows from this idea. This is another idea. 1 rev equals 1 circumference. That means, therefore, see this pile of rocks? That little pile of rocks over there means therefore. If you ever take advanced math classes, they're going to do that because they don't want to write the word therefore. Therefore, 1 rev equals 2 pi r. So you could use either of these boxes. Remember, the pile of rocks is therefore. Okay, so 1 rev is a circumference, therefore a circumference is 2 pi r. We need the orange, though, because we want rad. We want radians. So we're going to put 2 pi radians, which is how many degrees? 2 pi radians. 360 degrees. So we're putting 360 degrees is a revolution. Does that make sense to you? 360 degrees is a revolution. That's that. That's that. We have the unit we want, radians and seconds. So what's happening is we're multiplying the whole top and multiplying the whole bottom. So what we'll do is we'll take this. We could try to reduce, or we could just kind of go for it. Sometimes what I like to do is see the 60 and the 2. I'm kind of like, hey, why don't I make that 30? Why don't I make that 30? And I make that gone, right?
The same place has been listed. Thank you for your cooperation.
See how that's 2,800 and there's an extra 0 there? Why don't I get rid of that 0 if I feel like it? So what ends up happening on this option is I get 280 pi radians per 3 seconds. And we still need to divide it to get the actual answer here. But you also could do it on the top without worrying about that. You could kind of just multiply it all out. So let's just look at that for a second. So what I do is I multiply by anything in the numerator and I divide by anything in the denominator. So 2800 times 2 times pi, that's my whole thing, divided by, so that's whatever we just had, divided by 60. And that gets me 293.215. 293.215. 293.215 radians per second. That's our answer. This should come out to that. This is in terms of radians right now. This is about 3 and this is about 3, so it's actually going to work. This is called in terms of pi. I said in terms of radians, I meant in terms of pi. When you leave a pi in your answer, like the answer is 8 pi, that's in terms of pi. And sometimes it's a lot cleaner, right? Because pi is a really weird number. So 280 times pi, divide that answer by 3. Whoops, syntax error. What's up with that? There we go. 293.215. 293.215 radians per second. That's it. We've got it. So what I want to do is I want to talk a little bit about angular and linear speed, how we can use one to get the other. With the method that we've been using, we haven't really been focusing on the formulas, and because we haven't been focusing on the formulas, this isn't really even going to be a different problem type. It's all the same to us because we have been not using the formulas. But I will write down some things. If you think about velocity, that's going to be the arc length over time, right? The arc length is r theta, so that's over time, right? If you take the r out, I don't know that you need this, but feel free to write it if you like it. And then what is theta over time? Well, that's angular speed. So it's just showing how all these kind of things work together. Like arc length is r theta. You could pull that r out and have angular speed. This is angular speed from the previous page. So when we see the windmill that has the 14 feet long blades, that's going to be a radius of 14. Just keep that in mind. Just remembering that because a student asked me. Okay. So Ryan's riding his bicycle, or we got a ceiling fan. Let's do the ceiling fan. So I'm going to ignore the diagram, and I'm going to focus on what I want in the end. So again, let's highlight what we want quite literally in feet per second. So feet per second is the goal. So we'll go down here. We'll say, hey, we really do very much want feet per second. This is the goal. That's where our GPS is heading. It's taking us there. And we're starting with 40 rev per minute, RPM. I don't really want minutes, so how shall I get rid of minutes? Put it in top or bottom? Put it in top. So minutes. What do we want? Seconds? So how many seconds in the bottom? 60 seconds is 1 minute, is what we've decided. We can cancel the minutes. We have the seconds, this is what we want. We need feet. How can I get revolutions to feet? So this is, again, we're going to try to go back up here and look at what we had earlier. Revolutions to feet. Which one of these do you think is more likely to get you feet? The circumference or the 2 pi radians? Circumference. This is a distance. This radius is a distance. This is going to get you feet. So 1 rev is 2 pi times the radius. So all we have to do is put 1 rev on the bottom because we want to get rid of it, right? See you later, 1 rev. And that is 2 pi r. Well, r is 25. Inches, right? Inches. So we're going to wind up with the following. Now, if we want to, we can do a little canceling. Sometimes it's a little sketch, but we'll try it. So I see a 0 here, and I'm just going to get rid of a 0 and a 0, right? That's okay. You don't have to if you don't want to. I'm going to multiply the whole top, and then I'm going to divide by anything on the bottom. 4 times 2 times pi times 25, enter. That's the whole top. I'm going to take that answer, I'm just simply going to divide it Answer divided by 6, 104.720. 104.720. Oh my goodness, we're not done yet. I'm sorry to say it. Inches per second, right? What's our problem? What's the issue? We're in inches. We're not in feet, people. We're not in feet. So we got to get from inches to feet. We can do it pretty easily. So normally I wouldn't stop mid-problem like this. This was a mistake, but it's okay. We want to get out of inches. So 12 inches, which inches must go on the bottom to get rid of inches, is 1 foot. So basically we just divide that by 12, and we'll have the appropriate answer, which should be 8.727 feet per second. Okay, and that is rounded to the nearest thousandth. So let's just take a quick look and make sure that we are on track with that. Okay, so we're going to wrap up the video here. If you have this handout and you're able to, I would encourage you, and perhaps if you're in my class, I'm requiring you to do 7 and 9. So pause the video, maybe give those a shot, and we'll see you in the next video. Peace.